Okay, so we're going to start talking about similar triangles and what it means to be similar. So this kind of explains why we were just spending a lesson in geometry talking about ratios and algebra. And so the reason is because we're going to see that we have similar triangles here. So the way we write similar triangles, so here I can say that triangle ABC is similar to triangle DEF. And they kind of trick us here because DEF is rotated around. This symbol is similar to, so notice this means congruent. It's that same tilde on top of an equal sign, but now it's that same symbol just without the equal sign. So this means similar. These are similar. So they're not congruent, but they're similar. They're like each other. Okay, so if these are similar, in order for that to be true, then two things must happen. The first is that the angles must all be congruent. So that means that angle A is congruent to angle B, and that is congruent to angle C. So notice angle, oh sorry, I got that mixed up. Angle A must be congruent to angle D. Angle B must be congruent to angle E. And angle C must be congruent to angle F. Those are the relationships we need to see, and we can see that angle A is 30 degrees, as is angle D. We can then conclude that B and E are both the same at 60 degrees. So the angles are congruent. That's one thing. Also, we need the sides to have a common ratio. So we need AB to DE to be the same as BC to EF, which we need to be the same as CA to FD. Well, so if we look at this, AB is 12, DE is 9, BC is 6, and EF is 4.5, and CA is 6 root 3, and FD is 4.5 root 3. Well, we can do a little bit of algebra here to kind of play around with this. But actually, if you look, 12 to 9 and 6 to 4.5, those are actually pretty much the same thing, because if we multiply this fraction by 2 over 2, 6 times 2 is 12, and 4.5 times 2 is 9, we actually get 12 over 9. If we do the same thing here, realizing that we can cancel out those, we actually get 12 to 9. So because all of these ratios are the same, that means that these triangles are similar. And we can reduce that fraction to be 4/3. And so that's that common ratio. So in order for triangles to be similar, all three sides must be congruent, and the corresponding sides must be proportional. So that's a little bit different than congruent triangles, where the sides need to be congruent. Of course, we don't just need to look at triangles, we can look at other polygons as well. So we want to write a similarity statement and then find x, y, and ut. So RSTUV is similar to ABCDE. And now we want to write out the proportions for x and y to solve for x and y. Well, if we know that RSTUV is similar to ABCDE, we know that RS to AB is equal to ST to BC, which is equal to TU to CD, which is equal to UV to DE, which is equal to VR to EA. And not all these sides are listed. However, we know that they are similar. So if we look at x, x is RV. So that's right here. So x to EA, or AE, x to 3 is equal to, well, we just need any other two sides. Well, ST is there. Notice that's on the same triangle as the side with x. So we're going to have that both in the numerator. ST is 18. That's going to be proportional. That's going to be the same to BC, which is 4. Well, we can solve this now. So we have ourselves a nice little proportion to set up. So we get 4x is equal to 3 times 18, and 3 times 18 is 54. And 54 divided by 4 is 13.5. So x is equal to 13.5. We can do the same approach with y. So notice that this side TU is y plus 2, and TU is going to go to CD, which is 5. And we can do the same 18 to 4 that we had before. So we get 4y plus 8 is equal to 18 times 5. And then 18 times 5 is 90. So 4y is equal to 82. 82 divided by 4 is equal to 20.5. Y is equal to 20.5. And that's it there. So a nice little way to work through these problems. So we have to do a little bit of algebra. We have to set up an equation. But all we're doing is setting up some proportions to solve. So here's another application type problem. And then there are some more practice problems that we can do to solve. So let's go through this one first. So triangle ABC is similar to XYZ. And there it is. That common ratio is called a scale factor of 2 to 3. If the lengths of the side of ABC are 6, 8, and 10, we want to find the lengths of XYZ. And so we're going to write out the proportions for finding the sides. So we know that AB to XY is equal to BC to YZ, and that's equal to CA to ZX, and that's all equal to 2 to 3. So the lengths of triangle ABC are 6, 8, and 10. This problem did not do a really good job of the diagram, so we're going to assume that goes in order. So 6, 8, and 10, we will say. We want to find the lengths of XYZ. So AB, we said, is 6. We want to find XY, knowing that that scale factor is 2 to 3. Well, cross multiplying, we get 18 is equal to 2XY. So XY is equal to 9. BC is 8. So 8 to YZ is yet again equal to 2 to 3. So YZ, or 2 times YZ, is equal to 24. So YZ is equal to 12. And then finally, we get 10 to ZX is equal to 2 to 3. So we know 2 times ZX is equal to 30. And now you can see why I cross my Z's. And also that ZX is equal to 15. Okay. So setting up these proportions, writing out your equations is crucial in order to get the correct answers. All right, next we want to solve for x, and the polygons in each pair are similar. So these triangles, these quadrilaterals, these triangles, and these quadrilaterals are all going to be similar. So if we want to solve for x, it's this side here. So we get 8 8x minus 2 is going to correspond to 63. And that's going to equal, notice that 8x minus 2 is on the same polygon, same triangle as 42. So we're going to do that. We can actually reduce this fraction over here. They both have a common factor of 7. So I'm going to say that that's 8x minus 2 over 63 is equal to 6 over 7. And then I can cross multiply. So I get 56x minus 14 is equal to 63 times 6, which is 378. I'm running out of room, but what we would do is we would add 14 to both sides, and then we would divide by 56 to get that x is equal to 7. Over here, we can see that x minus 2 and 12 are corresponding. So we take any other two sides here, we can do 18 to 24. Yet again, these reduce. They both have a common factor of, let's see, would 3 be the largest one? 3 would be the largest factor. 6 would be the largest factor. So x minus 2 over 12 is equal to 3 to 4. We factor out a 6 from both of these. So we get 4x minus 8 is equal to 36. And yet again, running out of room, so 36 plus 8 would be 44. Dividing both sides by 4, we get that x is equal to 11. Over here, this is a little bit tricky because we can see that 30 and 35 are the smallest sides. So this is rotated around a bit. But this larger side is 6x minus 6 to 63. And if we do the smaller sides there, so 30 to 35, yet again, those two cancel out with a common factor of 5. So we actually end up getting 6 to 7. I can scroll down here. So 7 times 6 is going to be our 42. So we get 42x minus 42 is equal to 63 times 6, which is 378. So with that 378, we can add 42 and then divide by 42 to get that x is equal to 10. And then finally over here, you can kind of see that these go inward a little bit, kind of like this. So we know that they're oriented in the same direction as opposed to 17. So we know that 2x plus 4 corresponds to 45, much in the same way that 16 corresponds to 40. These have common factors, so we can actually reduce that. So if we, actually, they both have a common factor of 8. So we can reduce that even further, 2 to 5. Cross multiplying, we get 10x plus 20 is equal to 90. 10x plus 20 is equal to 90. So we get x is equal to 7 when we solve all of that. So those are some nice sample problems. So sometimes the hard part is realizing which sides correspond to which ones. But setting up the proportions is key, and then it's just a matter of cross multiplying to solve.